This is a demo of hijacking a session on Webgoat 5.4 using Burp Suite. Okay, so the first thing we're going to do is capture a request to the application. We already have our Burp set up as an intercepting proxy. Let's take a look at that. Let's reload it. We're actually looking for it to set a session cookie. Let's try it again. And here we go. We have the weak ID cookie here. From some previous testing, we've determined that that is the session cookie, not the session ID. Because if you get rid of this, the application will try to reset the cookie if you log in again. Or that's the cookie that the application sets when you log in. And you don't have to put a username or password in here. It doesn't seem to affect anything for the purposes of this exercise, since we're just dealing with intercepting session cookie. So what we actually want to do is let's forward that and make sure that our response has the set cookie header. Looks like it doesn't. Let's try that one more time. And in this case, what we're going to do is get rid of this cookie so that it forces the application to generate another cookie. And I'll show you why in just a moment while we're capturing this. Let's forward. Okay, this is the original request. Here we see the edited request without the cookie, and the response has set cookie. This is what we're looking for here. So what we want to do now is generate a bunch of these cookies to kind of see if we can see some pattern in the session cookies. So we're going to do, let's click on this request and send it to sequencer. It's already parsed out our weak ID cookie. I don't think we need any of the options set, so let's go ahead and start live capture. It's going to make that request over and over again and generate a bunch of cookies. Let's see if it's able to analyze with how many it has now. Okay, looks like that's probably enough. Okay, let's save our tokens to a file. And if we look at the character level analysis, without digging too deeply, we can tell that there's a lot of variance in this 4th position and in the 18th position, which corresponds kind of to the two sets of numbers in between the dash. So basically, we're looking at a lot of variance in this in the last two numbers of the first section and the last 2 or 3 numbers of the last section. So let's take a look at, let's open up our tokens file. And if we, first thing, let's just look at the last 2 digits here. Got 73, 70, 71, 72. It's kind of out of order, so I'm going to do sort. And now we see a little bit more of a sequence. So we look back, we see a gap here at 68. See one at 64 here also. Doesn't look like we have any more. There's probably a few more gaps if we keep looking, but let's see if we can figure out maybe what might be somebody else's session, since all these tokens are generated for our own session. What we can kind of surmise is that, or guess, is that if there's a gap in here, maybe that's the application setting a session cookie for somebody else. So to test that theory, we're going to copy this one. And we see a gap in between here is 6, 7, and it's missing 6, 8. So we're going to try to test that. We also see a gap from 3.5 to 40 here. We're going to use that in our attack also. So let's see, let's capture one more request with the session cookie set. So it has a session cookie set, so we're going to send that to intruder. And we're going to set our positions, payload positions. Copy paste the ID from our file in. Let's take a look at that again. And let's see, we were doing 2076768 is what we want to start with. And then what do we have? 35 through 40. So let's set this as a variable. And for our payloads, we're going to use numbers. We'll start with some of the ones that we know have already been used, just to see what the response looks like for those. And I don't think we need any options, so let's start attack. Okay, so looks like if we're not really seeing anything because all of the response lengths are the same, probably which probably just means that there's not that we're not getting a different response that would tell us, that we logged in as someone else or that we completed the lesson or anything like that. So it looks like maybe the ones we tried weren't somebody else's session cookies there. Let's see if we have any other options to check. This one there's a gap here, but there's not really a gap here. Don't know, it's a little iffy, so let's see if we can find something where there might be a few more than one cookie option to check. It's gap here. We could try between 18 and 20. Let's try that. Set this to 19. And we want to check 71 through 74. Okay, so for payloads 71, 73, and 74, the content length is pretty similar. but we have an anomaly here where for 72, content length is different. So let's check and see what that response was. Let's scroll down. We could try render, but it doesn't render very well in this small of a window. So we actually can see a little bit here. We can see, congratulations, you have something something this lesson. Let's just look at the, scroll down, look at the raw HTML, see what that looks like. And we see, congratulations, successfully completed this lesson. So the using this payload successfully hijacked another user's session. And if we go, we turn off intercept, and then reload this page, see check mark for successful completion lesson. So that's how you hijack a session with Webgoat and Burp.